Hey everyone, in this video I'm going to show you how you can make a 3D world similar to those seen in Counter-Strike and other games. I'm going to be showing you how to do this using a JavaScript library called Three.js. This video will not take long to make as there is not a lot of code, but you will be exposed to lots of Three.js methods that allow us to spin up 3D worlds quickly so that we can end up with something like this. Okay, so what are we waiting for? Let's get to it. Okay, so first things first, let's just start up a new project. I'm going to call this 3D world, just like so, and just create. Of course, you are free to use whatever code editor you wish. I am using WebStorm, and I've just essentially created an empty directory, sort of folder with nothing in it, to get started. So as you will see, here is my directory and there's nothing in it. The first thing that I'm going to do is just create a new file. So I'm going to go in here, click new, and I'm going to create an HTML file. So I'm just going to select that and call it index. And the HTML extension will be added for me along with some boilerplate code. So I'm just going to go ahead and call this 3D world. And before we do anything, let's get to essentially getting all of Three.js's magic in here. I'm going to use a script. So let's get up our script tag, making sure to spell it script, so that we can script. Thanks. Let's do it again, script. Wonderful, that is the one we need. And we also need a closing tag, thanks tab 9. So this is the one I need, and I am just going to link it to. Now we can use various packages. If you are familiar with NPM and the NPM registry, we can use pretty much those same packages with just simple JavaScript projects. I'm just going to show you where you can get certain packages from. Not as many, but definitely a lot. I think it's something like 4,000 packages are on here. The website is called CDNJS, and we can search from over 4,093 libraries. So I'm just going to search for Three.js. This is the one I want. And I'm just going to copy this first one right here. And I'm going to go back in here and just link it. So essentially what we have done is taken everything from Three.js, so all the methods that come with Three.js. I think if we visit this, you will see all the methods available to us. Okay, so we've essentially taken all of them. They are in here. It is a bit hard to read, but essentially every method that we use that comes with Three.js from now on is taken from here. Okay, so there we go. We have done it. I am going to use another one as well, because along with this script, I also want to use this is a Three.js thing, but for some reason it is separate. It's called orbit controls, and is essentially the thing that will allow us to orbit around and see the world, you know, in a 3D way. So going like, woo. So there we go. Those are the two scripts we need. Please go ahead and take them from here. And once we have those scripts, well, we need to write our Java script. So we can, of course, write all our JavaScript in here, or we can just link a file. So that's what I'm going to do. I'm going to choose to link a file just to keep all our JavaScript separate. So let's create an app.js file, making sure that this is after the two scripts up here. So now I'm just going to go ahead and create a new JavaScript file and call it app, just like so. So great, we have successfully linked our app.js file to our index.html file. While we are here, I'm just going to link a style sheet, even though there isn't that much styling that we are going to do, but there is just the tiniest bit. And as we are keeping everything separate, I'm just going to keep this separate too. So here is our style sheet. And let's go ahead and create a CSS file and call it styles. And wonderful. Now, as I said, there isn't much styling I want to do. I essentially just want to get rid of any margin from the body as well as the HTML tag. And I'm just going to make it 100%. And now I'm also going to do one more thing in here, and that is create a canvas element, okay? Because we essentially want to grab this element in our JavaScript so we can inject all of our scenes, all of our cameras, everything in our 3D world that we're going to be building. So let's give this an ID so we can pick it out. I'm just going to give it the ID of C. Ooh, like so. Okay, I'm just giving it the ID of C and save. And to style this again, I'm just going to get rid of some things. Do we need to get rid of margin? First of all, let's grab it. So I'm going to get the ID. So hash is for ID. The ID of C, I'm looking for the element with the ID of C. And I'm just going to make sure that our canvas has a width of 100% and a height of 100% so that it literally takes up the whole browser all the time, no matter how far you stretch the browser. I'm just going to say display block. Great. So now, I mean, you won't see much for now, but essentially if I open this, so let's open in browser Chrome, you will just see this, but know that essentially our canvas ID is taking up the entire space. As you will see, like here, it's taking up the entire browser. Wonderful. Cool, so we've got the setup done. Now let's get to, just gonna tab that out. Of course, feel free to format this a little bit better if you wish. But now let's get to using our app.js file that we have linked up along with all the methods that come with Three.js. And I'm gonna open up my app.js file and I'm gonna write everything in this function. And I'm just gonna call the function like so. So now the first thing that we need to do when working with Three.js is we need to set up a scene, a camera with a position and a renderer, okay? The renderer is actually to render the scene with the camera, but that I mean render from the camera's position and perspective. So that's three things that are a must. We need a scene, a camera, and a position when working with Three.js. So let's do it. Let's first set up a camera with a perspective and a position. So the first thing that I'm going to do is set up the things that we need to pass into my camera. So these are the FOV. Now the FOV, this is the extent of the scene that is seen. So the scene that is seen on the display at any moment. The default value for this is 50, and that is 50 degrees. So I'm just going to put that in there for now. The next thing that we need to pass into our camera is the aspect. So I'm just going to put in 1, but essentially the aspect, whatever value you are giving here, this just means however many times bigger the width is than the height. Okay, so if I put a 2 in here, for example, that means my image is, or my scene is twice as wide as it is high. So that is what aspect means. The third thing we need to pass into our camera is the const near, and near essentially is the clipping plane. So this means that if an object is closer than this value, so if I put in like 0.1, this is actually the default amount, then that will not be rendered, okay? We aren't gonna be having any objects that are less than 0.1 towards us, right? So hopefully that makes sense. As soon as it comes to 0.1, the object will disappear. And we also have a clipping plane for far as well. This is the default value for far, so I'm just going to put that in because we won't really be needing near and far. We're not going to have any objects in our scene. We're just going to be making a scene. So I've just put in the default values for now. Great. So now that we have our 4 values that we need in order to create our camera with a perspective, let's grab it. So I'm going to get the package 3. And I'm going to get perspective camera. Oops, that's not the right one. Perspective camera. I mean, it's the beginning of this. Let's try tab 9. Perspective camera, and let's pass through FOV and then aspect, near and far. Now, if you have an image that you're going to work with that, you know, isn't exactly 2:1 in aspect, you can actually, and this could be quite a cool thing, get the canvas that you are working with. So let's actually grab the canvas. So we're going to grab this element right here by the ID. So we can do so easily by getting the document query selector and passing through the ID of C. And let's save this as canvas. Okay, so I can now get the canvas client width and divide it by the canvas height. Okay, and that will give me the aspect. Right? Because if the width is double the height, then that will give me 2. So that is something you can do. So you can hard code the aspect, or you could just do it the lazy way and just grab whatever the canvas is width and divide it by the client height. I'm going to keep that there for you just in case you need to refer to it later. Great, so we have now set up our camera with perspective. Let's save it as something. I'm going to save it as camera. Wonderful. So we've got the camera. What the other 2 things that we said we need? We need the renderer and the scene. So let's focus on the renderer first. There are a few renderers we can use. The render is essentially what's going to render our scene based on the camera perspective. So it's really, really powerful. Like I said, there's a few we can use. For now, I'm just going to use the standard one for Three.js, which is WebGL renderer, like so. Okay, so once again, we need to actually grab this from 3. WebGL renderer, and let's save this as renderer, like so, and let's call it. Now, so this is the standard one we are using. There are also a few others which we'll use later, and also others for people who have old browsers that don't support WebGL support. Okay, so just be aware of that. If you want to have a look at them, please do look at the Three.js documentation. So great, we have created a render instance, and now we also need to somehow make the render happen in the canvas, right, that we have defined in our HTML and picked out here. So to do this, I'm simply going to grab canvas and pass it through like this. So now the 2 things are pretty much connected. We will also need to set the size of the render, right? Because at the moment we just have a render. So to do this, I'm just going to go ahead and get the width, which is actually going to be the canvas client width, the height. So once again, this is the client height, and I'm going to pass it through into set size, like so. And set size doesn't really come with 3. It actually comes with the renderer. So made an instance of this. Now let's go ahead and use it, because set size is something that comes out of that. Okay, great. There is one last thing to do, and that is actually render the rendering, but we won't be able to do that until we complete the 3rd part of the 3 must-haves, and that is creating the scene. So let's go ahead and do that. So I'm going to create a scene by first getting a scene from 3 and creating a new instance of it, and let's save it as scene so we can use it on later in our JavaScript. And now to add some texture to the scene, we're actually going to have to use something else from 3 called the texture loader, and call it like that. And once again, let's save this as something so we can use it later. I'm going to save it as texture. Great, so we've got the scene, we've got a texture loader. Now I'm going to use the loader. So essentially, let's call this loader actually, not texture, loader. I'm going to use the loader to load an image as the texture. So I'm actually going to use an image that we have from the Three.js documentation. Of course, you can use whatever image you wish, but I'm just going to show you what this looks like. So I'm going to open this up here and just paste that in here. And you will see an image that is essentially twice as long as it is high. And it's actually, it looks quite funky, right? Because it's essentially a 3D image that we are going to use. And I have put it in here for now, like so. And the second thing that we need to pass through into here is a callback function. Okay, so this is just the syntax for using the loader. So loading the loader. And what I want to pass through into here, well, we now need to get this whole texture. So maybe I'm going to define this as texture now. I need to get all of this texture, so the image, and I need to add it to the scene. So that I can do so easily by grabbing the scene, using background, and then assigning the texture to it. Wonderful. So we are nearly getting there. We have a scene now, we have a camera, and we nearly have completed the render, okay? Like I said, we need these three things to work before we can see anything in the browser. So now let's get to finishing off our render. To do this, I'm actually going to write a function called render. So let's go ahead and write the function render. That I can pass through the JavaScript method of request animation frame. So hopefully you've used request animation frame before. And then I'm going to actually pass through render as a callback into the request animation frame. Okay, and I'm actually going to do this outside the function too. And now inside of this function, so make sure you're inside the function above the request animation frame, I'm going to get the renderer and do the final piece. So I'm going to render the renderer. And like I said, to make this work, I need to pass through the scene, and I also need to pass through the camera. So there we go. So now if we look in here, and ta-da! So now we are getting the image show up because we use the camera, we use the scene, and then we pass them through into the renderer. But we are not yet done. Okay, so few things. So we said that we want to be able to orbit around, right? We want to be able to see everything. And we need to make this a 3D world. So the first thing that I'm going to do is change this into a 3D world. And to do this, we essentially need to get this image, so the texture. So let's get the texture, image, height, because we are essentially going to turn this image into a cube render. And for that, we need the texture image height. And we're going to wrap this in a method, again, from 3. So let's get 3. And I'm going to use WebGL, and this time cube render target. So that's another renderer that I was talking about, and don't forget the new. And let's save this as something. I'm just going to save it as RT for now. So there we go, target, making sure to spell that correctly. WebGL cube render target. I think that looks right. And now let's get that, and I'm going to essentially, so this image is called an equirectangular map, but I need to change it into a skybox. So there is a method for this that comes with that. So I'm gonna get that, which I have saved as RT, and use from equirectangular. Again, I hope I spelled this right. Equirectangular texture, and I'm going to pass through the renderer and also the texture to make it into a skybox that we can work with. So now I'm just going to stick RT in front of here, and that should now change it into the 3D box that we were talking about. Of course, we can't really see this yet as we are not orbiting, and there are a few things I would like to change. So let's go ahead and fix those now. So the first thing that I want to do is add the orbiter, which we imported in here. So I can do so easily. I'm going to do so, let's just do it here. We can do whatever we want really. New 3 orbit controls, and we need to pass through the camera and not the renderer but the canvas in order for this to work. And one more thing that we need to do for this to work is actually get our camera and give a position to it, and the position needs to be higher than 1 essentially for this to work. So we need to add a Z index, and I'm just going to give it a 1. So now if we look in here and refresh the page, ta-da, we can orbit. This is looking good. Amazing. We can, of course, mess around with these as much as we wish. So for example, if I change this to perhaps 75, there we go. That is looking much better. It's just sort of moved it away. Woo, amazing. So I'm really happy with how this is looking. One last thing I would like to do is actually change this so that it actually is more responsive to the browser and resizes on every render. So I can do this easily. In fact, I'm just going to move some things around. I'm going to set the size of the render. So let's grab these and actually fetch the height and width of the canvas each time this renders, and then set the size of the renderer in here. So that is what I'm going to do so that the resize happens with each render. And I'm also going to go and get the camera, which we defined above, and get the aspect of it and just change the aspect again. So once again, I'm just going to get the width and divide it by the height. And I'm also going to get the camera and I'm going to update projection matrix. And add false as a third parameter to set size. Ta-da! Now this will essentially sort of move with the browser instead of staying still, okay? So this is looking cool. I'm really happy with this. Of course, we can clean this up a little bit. Like perhaps we actually don't need this like so. We can replace it, but that is up to you. There we go. Cool. Okay, so there we go. There's our 3D, super simple 3D world. Hopefully this helps. Hopefully I've explained the code for you to understand what all of this means when you take it from my description below. And as always, please do read the Three.js documentation if you want to go into a deeper dive into any of these or explore more methods that come with Three.js. Thanks very much, and I'll see you soon.